Good morning, everyone. Thank you for joining us. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, broadcasting live Apple Valley, California.
Science and Technology Channel.
Yes, really interesting segment today. I say that a lot. A team of scientists from the University of Miami, in collaboration with two professors from Georgia Institute of Technology and University of Rochester, have developed a new kind of molecule that could revolutionize the chip-making industry by replacing silicon or metal, which are currently integrated raw materials in the production of computer chips. The study has been published in the Journal of American Chemical Society. Would you like to know more?
The researchers have shared what they believe is the world's most electrically conductive organic molecule, as per a statement released by the university. The study signals a novel possibility of manufacturing smaller, more powerful computing devices, which are composed of chemical elements found in nature, mostly carbon, sulfur, and nitrogen.
Organic. Yeah. Over the past 5 decades, the number of transistors on a chip has consistently doubled approximately every 2 years. However, and that's probably where we get that law where computers get faster and better every 2 years. That's probably where.
Smaller.
Yeah. However, as silicon-based electronics approach their physical limits, further miniaturization using traditional technologies is becoming increasingly difficult. This was a challenge Kun Wang, a physicist at the University of Miami, and his team aimed to solve. The researchers looked into how to use tiny molecular structures to conduct electricity. Quote, "So far, there's no molecular material that allows electrons to go across it without significant loss of conductivity. This work is the first demonstration that organic molecules can allow electrons to migrate across it without any energy loss over several tens of nanometers," Wang explained. Nanometer, very tiny, very tiny.
Yeah. According to him, the team's molecules are stable under normal, everyday conditions and deliver the highest known electrical conductance across molecular lengths previously thought impractical. This breakthrough could pave the way for classical computing devices to become not only smaller and more energy efficient, but also more affordable to manufacture.
Like that.
Yeah.
In most cases, a molecule's ability to conduct electrons drops sharply as its size increases, but the newly developed molecular wires, quote, defy this trend, acting as essential pathways for transferring, processing, and storing information in the next gen of computing.
This is a quote. "Once unique in our molecular system is that electrons travel across the molecule like a bullet without energy loss. So it is theoretically the most efficient way of electron transport in any material system." Wang noted, that was what he's the quoter, Wang, right?
Mm-hmm.
Not only can it downsize future electronic devices, but its structure could also enable functions that were not even possible with silicon-based materials, he added.
Yeah, I wonder what things could be enabled that weren't possible. I'd like to see that.
Yeah.
Holograms, maybe?
I have no idea how they make chips. So
this exceptional efficiency not only has the potential to shrink future electronic devices, but also opens the door to entirely new functions that silicon-based materials can achieve. Quote, "In terms of application, this molecule is a big leap toward real-world applications. Since it is chemically robust and air-stable, it could even be integrated with existing nanoelectronic components in a chip and work as an electronic wire or interconnects between chips," said Mehrdad Shiri, a member of the research team and a graduate student at Miami University. It's cool how they involve the graduate students into this. It's really cool.
We've talked a lot about nano stuff. Nano just means smaller, right?
10 to the minus ninth. Yeah. Really small.
Yeah. In addition, the materials required to create the molecule aren't expensive, and it can be synthesized in a lab. This molecular system operates in ways that current conventional materials cannot, offering new properties that could enhance the power and energy efficiency of computing devices without increasing costs. Okay.
Here's a quote. "The ultra-high electrical conductance observed in our molecules is a result of an intriguing interaction of electron spins at the two ends of the molecule. In the future, one could use this molecular system as a qubit, which is a fundamental unit for quantum computing, weighing stressed.
Hmm.
I mean, we're getting into quantum computing now, so it seems logical to go that way with.
So
small
are
molecule.
we ready for the next level of computing? Oh, is that where we're going with this?
Yes, I mean the qubit was taking it that way, and now this molecule is going to make current electronics cheaper and smaller and help with the quantum computing. I think it's awesome. Like we were talking about, like Apollo 1, 2, and 3, those computers probably
They were gigantic.
they fit on this iPhone right now,
They were
stuff from back then. Yeah.
Yeah.
Yeah. Who knows? Maybe this might be the size of your thumbnail, in 20 years, 10 years,
Yeah, and they embed it in your
and
in your skin
synapse,
somewhere in your body,
Yeah. Yeah.
and you think the processing rather than have to type or.
That'd be so much faster, wouldn't it? So much. Just think
It
of
would wear. Could you imagine it would? And some people, the way they think, it would blow that thing all to smithereens. Probably.
imagine
there-
gaming. Gaming, you could have instant decisions from your mind to drop this totem or cast this spell or get out of the way here, and it'd be instant instead of using the thought going to your hand to move on the mouse, and it's just crazy.
I'll take your word for it.
All right, folks, thanks for joining us. We'll talk at you later.
Take care, everyone. Thanks.